Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. My name is Nooradila binti Muhammad Rawi. I'm a master student in polymer engineering from School of Chemical Engineering and Energy Engineering, Faculty of Engineering, University Technology Malaysia, Johor. On behalf of my research group, Nur Izian, Shazana Muhammad Yusof, Mauzi Wahid, Agus Arshad, Syukur Abdul Hassan, I would like to present on today's topic on the effect of Rami fiber loading on the mechanical properties of Rami reinforced recycled polyethylene terephthalate recycled polypropylene composite. So this is the outline of my presentation today. Consists of 6 main areas, starting with the introduction, problem statement, research objective, methodology, results and discussion, and also the conclusion. So for introduction, first and foremost, before I go further with this topic, I am very happy to explain here the motivation of choosing this topic. In recent years, natural fiber has been getting attention from most researchers to be an alternative to replace glass fiber reinforced polymers. This natural fiber composite can also help to conserve nature and preserve non-renewable resources. For PET is widely used in the manufacturing industries today, especially for plastic bottles. Efforts toward the recycling and reuse of PET products are perceived to be successful because of the number of PET waste is increased, especially in the packaging industries, according to R. Nonato 2016 and R. Kumar 2018. This is the example of the material that we use in our research. Okay, so for the fiber, why we choose Rami fiber instead of any other fibers? According to S. Mitra 2014, Rami fiber is one of the finest textile fibers in the world. It can be extracted from the skin of Bermuda nivea. Rami also can grow rapidly until it can be harvested every few months. Rami is one of the natural fibers with the highest of young modulus and tensile strength. It is in second place after flax and hemp and slightly lower than kenaf, according to N. Yan Waidu 2015. So for problem statement, there are many studies that have been conducted on PET PP blending with natural fiber reinforced composite with or without compatibilizer. However, studies on blending of recycled PET and recycled PP with Rami fiber present and polypropylene grafted maleic anhydride PPGMA compatibilizer have not been reported. Therefore, by exploring this study, we could identify the optimum fiber loading to achieve the best mechanical properties. Next, we go for research objective. So this study aims to compare the mechanical properties of Rami fiber reinforced recycled PET, recycled PP composite with varying the fiber loading from 5 to 25 PHR. Next is methodology. So the material we use in this research is recycled PET, recycled PP in the form of flakes. The compatibilizer we use is PPGMA. The fiber we use a Rami fiber that obtained from Wonosobo, Jawa Tengah, Indonesia. So for treated the Rami fiber, we use a sodium hydroxide. Okay, for composite preparation, the recycled PET, recycled PP blend ratio was set at 19:10, which is the best ratio mechanical properties according to Hidayah 2018. So the mixture then added with the PPGMA at constant loading of 5 PHR. The Rami fiber were introduced to the blend with different fiber loading from 5 to 25 PHR. And the sodium hydroxide we use at constant loading of 5%. The extruded was cooled and cut into small pellets and dried for 24 hours. For mechanical characterization, tensile and flexural test was conducted using Instron University Tester according to ASTM D638 and ASTM D790. For notch isot impact test, we use an Electron according to ASTM D256. For morphological analysis, we use a variable pressure scanning electron with a magnification of 500 from each sample. So this is the main area that I will discuss today, the results and also the discussion. For tensile strength properties, from figure 1 here indicates the effect of rami fiber loading on the tensile strength in recycled PET, recycled PP composite. It clearly here that the increase in the fiber loading will increase the tensile strength. The strength of the composite is also influenced by the good fiber dispersion throughout the composite. As mentioned by S. Orsted 2010, a uniform tensile distribution which depends on the fiber volume produces good mechanical properties in the composite. The tensile strength value obtained at 25 pHr Rami for 100 micrometer fiber size is at its maximum level due to the stronger surface interaction between fiber and the matrix. Next is tensile strength properties. Figure 2 shows that tensile strength at break. The tensile strength at break decrease with the increase of fiber content due to the inability of the fibers to withstand the loads transferred from the matrix. It can be observed that tensile strength value at 5 pHr Rami is higher than the 25 pHr of Rami because Rami fibers are assimilated in the matrix. The rigidity of the composite limits the flexibility of the recycled PET, recycled PP matrix, and Rami fibers. An increase in the fiber content in the polymer composite will cause the composite to become rigid because the phase ratio of the elastic matrix has been replaced by the brittleness of the fiber content. Next is tensile modulus properties. As shown in figure 3, the tensile modulus at different fiber contents from 0 pHr to 25 pHr was observed. The modulus value of natural fiber reinforced composite increased with increasing the fiber loading. Tensile modulus value at 25 pHr Rami fiber content is the highest with 5.2 GPa. This increase in tensile modulus responds to the resistance of rigid and strong fibers through the matrix so that the new composite becomes more rigid than the matrix. High loading of Rami fiber in recycled PET, recycled PP composite leads to high brittleness. Brittle materials tend to show very low elongation because they do not plastically deform. Next is flexure strength. From figure 4 here, the flexure strength starting to decrease from 11.7 megapascal and reaching a minimum value 10 megapascal at 25 pHr of Rami fiber loading. This decrease can be attributed to the accumulation of Rami fibers at higher loading resulting in poor adhesion. It can also be associated with non-uniform diameter and length fibers, poor specimen variation, higher void content, and measurement variation that can result in lower performance. Next is impact strength. It can be seen that the impact strength decreases with increase of fiber content. The difference in impact strength of Rami fiber composite with unreinforced recycled PP, recycled PET was not significant at the beginning of the Rami fiber adhesion, which is at 5 pHr. The increase in fiber content has increased the aggregation of fibers that form areas of high stress concentration where cracks can be initiated or easily spread. Deformation will occur on the composite when fibers are added on the matrix and it interferes with the local movement of polymer chains in the matrix, causing the impact strength on the Rami content of 25 pHr to be low. Last one is the scanning electron micrograph. The effect of Rami fiber on the properties of the blends can be evaluated by comparing the morphologies of the blends with different Rami fiber contents. As we can see here from figure A, the fiber pull out and voids have occurred at 5 pHr of fiber loading, whereas in the 25 pHr of fiber loading, we can see here there are some fiber breakage. The Rami fiber is completely covered by a composite matrix, showing that good bonding between the fiber and the matrix happened. So due to the impact test result, the recycled PET, recycled PP with 25 PHR Rami has the lowest value. This may be due to the interfiber interaction that occur between the Rami fiber and the matrix, resulting in fiber breakage, and it blocking the effective stress transfer from between the fiber and the matrix. The SEM image also showed that the Rami fiber has absorbed the applied energy, which result in fiber breakage. For conclusion, the tensile properties impact strength, flexural strength, and morphology of the Raman fiber reinforced recycled PET, recycled PP composite were compared to those with unfilled recycled PET, recycled PP blend. Fiber content influenced the mechanical and the morphology. The result from the tensile testing showed that the addition of high fiber loading increased both the tensile strength and tensile modulus. Contrariwise, the incorporation of high fiber loading decreased the impact strength and flexure strength of the composites. From SEM examinations, the impact fracture revealed poor adhesion in the composite structure, and the failure were caused by fiber pull-out and some voids at the low loading of fiber. We can see here that the produced Rami fiber reinforced recycled PET, recycled PP composite could potentially be used for engineering application for a wide variety of commercial applications in the near future. That's all for my presentation today. Thank you. Assalamualaikum.